So differential amplifier, we apply two input signal. So output is a difference of two input signal. So single-ended and differential operation. So single-ended signal, that is measured with respect to fixed potential. So this is a single-ended signal. So differential signal, that is measured between two nodes that have equal and opposite signal around a fixed potential, that is a differential signal. So we go for the differential operation because it's having the higher immunity. So differential signal we prefer. Now see the basic differential amplifier. We apply the input V in 1 and V in 2. The tail current is ISS. So ID of M1 and M2 is ISS is equal to ID1 plus ID2. For the differential amplifier, we are using the MOSFET of the same type. The resistance RD and RD2 are equal. So RD1 is RD equal to RD2 is equal to RD. So if Vin and Vin2 are equal, then the drain current is equal, that is equal to ISS by 2. Now output common mode level is, output voltage is VDD minus drop across this resistance. So VDD minus drop across resistance RD, that is ISS by 2 into RD. Now the DC analysis of this circuit, on x-axis we will take V in 1 minus V in 2. On y-axis we will take the output 1 and output 2. Now if V in 1 minus V in 2 varies from minus infinity to infinity, the condition 1 is that if V in 1 is more positive than V in 2, so transistor M1 is off. So when this V in 1 is more positive than V in 2, so input of this transistor is more negative than input of V in 2, so transistor M1 will off, so no current flowing through this. So Vout1 is equal to VDD. So Vout1 is equal to VDD. So for this region, V in 1 is a negative, so we are discussing this this quadrant. So output 1 is equal to VDD because transistor M1 is off, ID1 is 0, so ID2 is equal to ISS. So in that case transistor M2 is turned on, so output voltage is equal to VDD minus drop across this resistance. So output voltage is equal to VDD minus ISS into RD. Now when Vin is very close to the V in 2, in that case a transistor M1 is on, so it will draw some part of the current ISS, so ID1 start to flow. So Vout1 will goes on decreasing because ID is increases. So Vout1 is equal to VDD minus ID into RD. So output goes on decreasing for this part. So ID2 is decreases, so Vout2 will goes on increasing. So in this case Vout2 will goes on increasing. Now when V1 is equal to V in 2, at this point, whenever V in 1 is equal to V in 2, ID1 is equal to ID2, and that is ISS by 2. So Vout1 and Vout2 are equal because input is same, and that is equal to VDD minus RD ISS by 2. If V in is more positive than V in 2, V in 1 is more positive than V in 2, M1 carry the current greater than M2, so Vout1 will drop below the Vout2. So for higher value of V in minus V in 2, so in this case, in this region, so Vout1 goes on decreasing and Vout2 goes on increasing. So V in 1 is more positive than V in 2, M1 carries the current greater than M2, so V out 1 will drop below the V out 2. So V out 1 will goes on decreasing and V out 1 goes on increasing. So for the high values of V in minus V in 2, M1 carry all the current of M2, so V out 2 is equal to VDD and V out 1 is equal to VDD minus ISS into RD. Now common mode behavior of the circuit. To find the minimum and maximum value of CM level, so ISS is implemented by the NMOS. This is a current source. By applying adjusting proper gate voltage, this MOSFET 3 can be act as a current source. So ISS is implemented by NMOS. So V in common, that is vary from 0 to VDD. So transistor, whenever this transistor operated in a deep triode region, it can be represented by the resistor. So this is a common mode behavior of the differential amplifier. We apply the same signal. So common mode signal means both the signal are having the same amplitude and both are in a phase. That is a common mode signal. For the common mode, we will plot a graph of input and graph of ID and ID1. So whenever this input is a less than VTH, so transistor M1 and M2 is off. So when Vin is less than VTH, transistor is off, so ID is equal to 0. When Vin is equal to VTH, transistor will turn on, so ID start to increase when Vin increases. Now this is a graph of Vin and Vp, so Vp is the point here. So this is a source follower, so Vin is equal to VTH, transistor is off, so no voltage at this point. When Vin is equal to VTH, transistor will turn on, so Vp will follow the input. Now the graph of V out 1 and V out 2. So whenever input is less than VTH for this region, both the transistor are turned off, so V out 1 and V out 2 is equal to supply, because there is no drop across RD. So V out 1 and V out 2 is equal to supply, that is the VDD. So when V in is equal to VTH, transistor will turn on, so current is flowing through the transistors and the output goes on decreasing. So output is equal to VDD minus drop across this. So see the case number 1, if V in CM is a 0, both the transistors are off, so current is a 0, so output 1 and output 2 is equal to VDD. So this is the region. Now MOSFET M3 in a deep triode region, so we can apply gate voltage that is very high. So when V in is a positive, both the transistor will turn on. When V in is greater than VTH, so ID1 and ID2 will increase, so voltage at P node will increase. So M1 and M2 is a source follower which will track the input V in. So for high value of V in, drain to source voltage of M3 will exceed VGS3 minus VTH3. So M3 is a saturation region, so total current through M1 and M2 remains constant. So see, this V in is equal to VGS voltage plus this voltage. So V in CM is greater than VGS1 plus whole dry voltage of M3, that is VGS3 minus VTH3. So input voltage is greater than VGS1 plus VGS3 minus VTH3. So equation A. Now if V in increases further, so output V out 1 and V out 2 are relatively constant, so M1 and M2 is operated in a triode region. So if V in CM is greater than V out 1 plus VTH, what is the V out 1? VDD minus drop across RD. So V in CM is equal to VDD minus ISS into RD by 2 plus VTH. So this will set the upper limit of V in. So V in CM is bounded as follows. So V in CM is less than greater than VGS1 plus VGS3 minus VTH3, less than minimum value of this equation B. So equation A and equation B will decide the common mode range and for the input. So greater than VGS1 plus VGS3 minus VTH3, less than a minimum value of VDD minus RD ISS by 2 plus VTH or VDD.